Okay, welcome to the video on the Australian method. We didn't really talk about this too much in class. However, this is another method for complex trinomials. So again, to remind us of what a complex trinomial is, it is a trinomial where the first term in that a position next to the x squared cannot be factored out to give us 1 from the rest of the equation. So in this case, we have 3x squared minus 13x plus 14. What we'll notice is that you cannot common factor out the 3 from negative 13 and 14. It just isn't possible without giving us decimals. So this means that this is a complex trinomial, which means we need to use different methods. So like with decomposition, we're going to start by creating a new product. And we do that by multiplying the first term here, 3 by 14. So if we multiply 3 by 14, so I'm just going to write that out, we're going to get 42. So that is our new product. Our sum remains the same at negative 13. At this point, we're going to do the same thing that we were doing with decomposition, which is finding out our factors of 42 and what their sums are if we add them together. So our first one is 1 and 42. Okay, well that gives us 43. Not what we're looking for. 2 and 21. That gives us 23. Not what we're looking for. 3 and 14. Okay, that gives us 17. We're getting closer, but still not what we're looking for. Okay, we're going to try dividing 4 into 42. That gives us a decimal. We don't want that. 5 into 42, again, gives us a decimal and not what we're looking for. 6 into 42 does work because if we do 6 times by 7, we get 42. And it adds to 13. Well, okay, it's close to what we want. We have 13, but we want negative 13. So if we rewrote it and said negative 6 and negative 7, still multiplies out to positive 42, but that gives us our negative 13 that we want. Okay, so what we're going to do here with the Australian method, which was slightly different than the methods we've been using before, instead of decomposing this part here, decomposing the negative 13 into negative 6x and negative 7, we're going to open up our brackets. We're going to have a 3x here, minus 6, and a 3x here, minus 7. Now, the reason this is called the Australian method is because we're not done. We're going to put down under our 3, what we couldn't common factor out. So we put it on the bottom. Next step is now to try to see if we can get this 3 to cancel out. So we're going to look at our first bracket. We have 3x minus 6. Can we factor anything out from that? As it turns out, we can. We can factor out that 3. So we get a 3 on the outside. 3 divided by x. 3x divided by 3 gives us x. And negative 6 divided by 3 gives us negative 2. Okay, looks good. 3x minus 7, there's nothing that we can factor out from there. So we're going to put over the brackets 3. Now, what you're going to notice is that these two 3's can cancel each other out. And we are left with our expression x minus 2, end bracket, 3x minus 7. And that is our factor. This Australian method, how to keep you to remember it, is the idea that we're going down under, ha ha ha, play on the fact of what they say in Australia. Aussies say We're in the down under for Australia, and this is how you can kind of remember this version. This is another version that you can use that's very similar to decomposition. If I slide back over, you'll notice that we get the exact same expression, just with maybe one last step. So we're going to do another version of the Australian method again here. So our first step is to get our new product, because we can see that this is a complex trinomial and we cannot common factor out that 2. So our new product is going to be that 2 times negative 15. Again, I'm going to switch that x to a lovely little dot, which gives us negative 30. And our sum remains 13. So let's try this out. Let's see what we get here. So we want to find our factors of negative 30. Because we know that our product here is a negative, we know that one of our numbers is going to have to be negative and one of our numbers is going to have to be positive. That is how we're going to get a negative number. So we're going to try out different methods in order to get that negative 30. So our first one, as always, is going to be negative 1 and 30. Always. That's going to give us 29. And if we reverse it and do negative 31, we get negative 1, we get negative 29. Again, not what we're looking for. So let's try this again. Let's try negative 2 and 15. That multiplies out to 30, and if we add those together, we get 13. Okay, that's what we want. Now, again, with the decomposition method, we would have broken down this plus 13. Instead, what we're going to do is open up our brackets. And what I mean by that is we're going to have this first number here in our bracket. So we're going to start off with 2x, and we're going to put in negative 2. And we're going to have 2x, and we're putting in that other number, our 15, plus 15. And because this is the Australian method, we're going to go down under and put the 2, which is this a value. Okay, so we're there. Now we need to see if we can common factor anything out from these expressions. If we look at the first one, we have 2x minus 2. We can see from that that we can common factor out a 2. Okay, so if we're common factoring out the 2, we're going to get left with 2x divided by 2 leaves us with x. Negative 2 divided by 2 leaves us with negative 1. We're going to close bracket. 2x plus 15. That remains the same because we cannot common factor anything out from that expression. And because this is the down under method, we keep that 2 on the bottom. What you're going to notice here is that 2 in the front and the 2 on the bottom cancel each other out. And now we are left with our expression x minus 1 and bracket x plus 15. And that's how you do the Australian method. It's similar to decomposition in the beginning, but instead of breaking down this number here into its 2 parts, we open up the brackets and we put our factors in the bracket, keeping the front number, 2x. We just pretend that 2 doesn't exist there. And we try to common factor out the 2 that's down under in order to eliminate it and get a nice clean expression at the bottom. So that's our Australian method. It's one of our tools in our arsenal in order to factor out quadratic formulas, those trinomials that we are dealing with.